Objective A, solve proportions. Number 1, 3 over 4 equals 12 over n. As we said in the previous section, if you have a rational expression equals another rational expression, it's called the proportion. To solve proportion, the most effective way will be cross multiplication. So you simply cross multiply. If I cross multiply, I will have 3m equals 48. Divide both sides by 3, I have m is 16. Once you get your answer, do not just conclude right away. You need to check the restrictions. We have one variable part in the original equation, which is right here, m, and that cannot be 0. So our restriction says m cannot be 0, but our m is not 0, so it's totally fine. That's number 1. Number 3, again we have another proportion. So cross multiplication, 50x plus 150 equals 50. Move that 150 to the other side. We have 50x equals negative 100. Divide both sides by 50, x is negative 2. Do we have any restrictions? No, because we don't have variables in the denominator. So we could safely say that the answer is probably correct. Number 5, another proportion problem, cross multiplication. We have 6w equals 4w plus 8. Move that 4w to the left hand side, you have 2w equals 8. Divide both sides by 2, w is 4. Do we have any restrictions? No, we don't, because there's no variable in the denominator. Number 7, cross multiplication. We have x squared plus 4x equals 12. Since the coefficient of x squared is positive on the left hand side, I'm going to move that positive 12 to the left hand side. X squared plus 4x minus 12 equals 0. Factor the left hand side. We have x plus 6 times x minus 2 equals 0. By zero product property, each of these two factors could be 0. So we have two solutions potentially, negative 6, positive 2. Do we have any restrictions? Yes. We do have a variable part in the denominator, which is right here. X plus 4 cannot be 0, which indicates x cannot be negative 4. Our answer is totally fine. Number 9. Number 9, if you do cross multiplication, you can get your answer, but in this case, I'm not even going to bother doing cross multiplication. Why? Because they have the same denominator, x minus 2, x minus 2. If they are the same, that means their numerator must be the same. So n must be the same as 5 plus n. And we just need to solve this for n. If I solve this for n, we don't have a solution. Right? If I subtract n from both sides, I got 0 equals 5, which is false. So our conclusion will be no solution. If you do cross multiplication, you will find out that your solution is 2, but n cannot be 2 because the denominator cannot be 0. And the same conclusion, we don't have a solution for this one. Objective B, solve applied problems involving proportion. So most likely you have to create the proportion yourself for these word problems. Let's look at number 11. A trucker drives 57 miles on 6 gallons of gas. At the same rate, how many gallons of gas will it take him to drive 133 miles? This problem is a direct variation problem, meaning that as one of the category increases, the other category also increases. That's called the direct variation. So we are going to set up the proportion. I'm going to list out the two categories that we have. We have the miles and we also have the gallon of gas. I'm gonna create a proportion, miles over gallons of gas. That is our verbal model for this particular proportion. Once you have this model set up, you simply plug in the numbers. 57 miles corresponding to 6 gallons of gas equals, on the other side will be the question, 133 miles. And how many gallons of gas? So you just make it a variable. You can make it an x or any other variable that works for you. And we simply solve this for x. The best way to solve this, again, will be cross multiplication. So 57x equals 6 times 133. If I divide both sides by 57, I will get my answer, which is 14. So your answer will be 14 gallons of gas to drive 133 miles. Number 13. A runner travels 5 miles in the same time that a cyclist traveled 20 miles. The speed of the cyclist was 12 miles per hour, greater than that of the runner. What was the cyclist's speed? This is a motion problem. Write down the formula first. Rate times time equals distance. And then you set up the table. We have 2 players. One is the runner. The other one is the cyclist. And then we're going to fill in the table. First, let's make the variable. What was the speed of the cyclist? So in this case, we could make this our x, and I could put in the table x right here next to the cyclist. And then according to the question, the speed of the cyclist was 12 miles per hour greater than that of the runner. Therefore, the runner's speed will be x minus 12. As for the distance, it's given by the problem. The runner traveled 5 miles, so distance is 5. The cyclist traveled 20 miles, so it's 20 right here. According to the formula, we could write down the time that it takes for them to travel those 2 distances. For the runner, the distance is 5. The rate is x minus 12. So if I do a ratio, that is the time. Similarly, cyclist distance is 20, rate is x. Perform a ratio, that is the time. And according to the question, a runner travels 5 miles in the same time that a cyclist traveled 20 miles. That basically means these 2 quantities, the time should be the same. And that's our go-to setup equation. 5 over x minus 12 is the same as 20 over x. And that is our equation. Again, this is a proportion which can be easily solved by cross multiplying. So if you cross multiply and solve for x, you will get x is 16 miles per hour. And again, the key part of these questions are not about solving the equation because we already practiced enough. The key is to set up the equation, how you set up your proportions, which is very important. And that's the answer to question number 13. Question number 12 and question number 14 are very similar to these 2. Hopefully you will be able to find the answer. Thanks for watching.